So far, we've looked at the probability of different kinds of outcomes, simple outcomes, and outcomes, and or outcomes for a single event, flipping one coin, rolling one die, choosing one card, or picking one member from a population. What we're going to look at this time is a sequence of events. Suppose we flip a coin 3 times, what's the probability of a particular outcome? And we're going to start with the easiest of those this time and then move on to some slightly more complicated and involved methods for this. We're not going to go too far in the weeds here. We're going to keep these pretty straightforward, so don't worry about this. The key to what we're doing here is that these events are going to be what we call independent events, meaning the outcome of the first event does not affect the outcome of the second, and the outcome of the first two do not affect the outcome of the third, etc. And coin flips and rolls of the dice fit this description. Whatever I flip with a coin on the first flip doesn't affect the coin. The coin's unchanged. It's going to have the same probability of 1 and 2 for heads or tails on the next flip and on the flip after that. People sometimes talk about a gambler's paradox, where I feel like if I flipped a coin 5 times and it's come up heads each of those times, then it's got to be tails. I'm due for a win on the next one. It doesn't work that way. The probability stays at 1 out of 2. So that means that flips of a coin and rolls of a die are what we call independent events. The outcome on subsequent events is not affected. They're independent of what happened on the previous events. And that makes something like this very easy. Suppose we flip a coin 3 times. What's the probability that it's going to come up heads all 3 of those times? Well, if we're dealing with independent events, this is very easy. All we have to do is multiply the probability of heads on the first flip times probability of heads on the second times probability of heads on the third. Now compare that to what we've been talking about when we talked about and or. We did a little bit of addition and subtraction. Now we're talking about a sequence of events. We're talking about multiplying. So we're multiplying here 1/2 for the first flip, 1/2 for the second, 1/2 for the third. That's going to give us 1 out of 8, which is 0.125, which is about 12% of the time. And if you want to, you can try this. You flip a coin 3 times, count how many heads you got. Flip it again 3 times, count how many heads you got. Keep track of those, and if you do it about 16 times, you should end up with all heads about 1/8 of the time. So you should end up with all heads maybe 1 or 2 or 3 times out of the 16 times you do that. What if we flip a coin 4 times? What's the probability we would get 4 tails in a row? Well, that's going to be the probability of tail, which is still 1/2, times probability of tail, times probability of tail, etc. for 4 flips. And that's going to give us 1 in 16. Life doesn't get terribly interesting. Sequential, independent events. There's nothing complicated about them. It's always just going to be probability times probability times probability. What if we roll a die twice? What's the probability we get both 5s? Well, on the first roll, it's 1 in 6. On the second roll, it's still 1 in 6 because the die hasn't changed. So we get 1 in 36. Very simple stuff. Next time, we're going to look at a slightly more involved method for finding these, where we're not just going to look at what's the probability all heads, but what's the probability if we flip a coin 3 times, we get 2 heads and 1 tail, but we don't necessarily care what order those come in. That's going to be a little bit more involved. We'll bring the sample space into the picture here, and we'll do that. I'm going to do that in about 5 minutes. I have no idea when you're going to do it.